So with this video, I want to go over my slides for section 3.3, analyzing graphs of quadratic functions. So basically, I have the graphing quadratic function of the type of f of x is equal to a in parentheses x minus h squared plus k. So if I take just the parabola, a parabola is just x squared. And let's get rid of the a, the h, and the k. And I want to transform this x squared into the graphic quadratic function type, like so. If I multiply by a, remember in chapter 2 when we discussed about vertical stretching or shrinking and reflection across the x-axis or y-axis and stuff like that. So if you need a refresher, just go back to chapter 2 and remember those shifting transformations and what each part of adding to the function will do to the graph. So putting the a on the outside, we know it's going to be either vertically stretching or shrinking. If I put a minus h inside with the x, that's going to be a horizontal translation, and anything on the outside of the function is going to be a vertical translation. So this is where we're taking the basic parabola and adding things to it to do the translation or transformation. For this one here, we're going to talk about vertex. Vertex is basically where you see the graph turn or change direction. So if I'm coming from, I read a graph from left to right. So if I'm coming down, I see that it changed direction at this point because now it starts to increase. So we decreasing and now it's increasing. So at the change of direction, it's called the vertex. So same thing here, coming up, I stop here and start to go down. So that change of direction is going to be considered to be the vertex. The axis of symmetry is just basically we can draw a dashed line straight down the middle of the graph. So it kind of splits it in two. So here, this is going to be x minus 3, and this is going to be x equals to 1. So where did the negative 3 come from? Where did the 1 come from? Well, once we figure out what the vertex is, the x value in the vertex will always be the axis of symmetry. So here we see that x is equal to negative 3, and you always have to remember to put x equals, because remember we're trying to draw a line, which you need an equation, so you need the equal sign with that. So again, in MyMathFS Plus, if you just put down the answer of negative 3, the MyMathFS Plus is going to mark it wrong. You have to put x equals whatever the number should be. Over here, the vertex is going to be 1, so that's why the axis of symmetry is x equals to 1. The y we're considered to be the minimum or maximum. So look at the location of the vertex. Because the vertex is at the lowest point, that's considered to be a minimum. This vertex here is at the highest point. That's a maximum. So lowest point, minimum, highest point, maximum. And the y, in this case, is always going to be the number or the maximum or minimum in this case. So looking at the equation here, the h and the k is going to give us the vertex. So if we have the equation, remember this here in our regular equation, it has to be a minus sign. So in order to create a minus sign, these two negatives here make this plus sign. So if I originally was given a plus, x plus 3, to get this back to a minus so it can match the original equation, we need to make this a minus. That makes these two minus and have this a plus. So my h is considered to be negative 3. That's how they got it for the vertex here. Whatever's on the outside, this one here is considered to be minus 2. That's when we're going to actually keep it minus 2 for the vertical translation, which is going to be our k. So number in the inside beside the x, that's going to be our x. Anything on the outside is going to be our k for our vertex. So another way of looking at it, if you look at the one beside it, if you just change the sign, so this is a plus 3, make it a minus 3. Whatever's on the outside, you just keep it the same. So this is minus 2, you keep it minus 2. So over here, I have a minus 1. So because this subtraction here matches, this is considered to be a positive. So we have or here, or you can again, you just change the sign. This you think is minus 1, just change it to positive. So inside with the x's, we just change in the signs. The outside stays exactly what the sign is given. So that's a positive 3, keep it a positive 3. So looking at this one here, again, if this is a minus 1/4, and this is a -2, we're going to keep the sign. Change the sign here to be a positive 1/4. And then over here, you keep the sign over here would be -2. Axis of symmetry, because we know what the x is, it's going to be x equals 1/4. Now, how do we know this is a max or a min? If you actually put this in your calculator and the y equals and hit graph, you either going to see it make a open upward or it opens downward. The opening is going to be downward or opening is going to be upward. If it's a positive equation, it's always going to open upward. If it's a negative in front, it's always going to open downward. So here, the 3 is positive, so we know it's going to be it's going to open upward. So that's why we're going to get a minimum for the vertex. It's going to be at the bottom. So the minimum down here because of the positive. Now this is a negative here. So think once again, a positive, you have a nice happy smile. If you have a negative, that's nobody wants to be negative, so we're gonna have a frowny face. So that's why it's gonna make the creation of a frowny face. So the maximum here will be at the top. So looking up here for the vertex, if I look at the vertex, again, change the sign. So this is going to be a -5 and a +7. -5, +7. Change the sign, keep the sign. The axis of symmetry, x equals to whatever the vertex is. This opens downward, frowny face. I have a negative here, frowny face here. So it's going to have a maximum point as a vertex. And there's going to be no minimum because we already know it's a maximum. You're either going to have one or the other for a parabola. So back in section 3.2, I made a video as far as how to complete the square. So you always wonder if you wanted to know why we need to know to complete the square. This is one of the reasons why we need to learn how to do the complete square, because what we're going to do is we're going to transform this equation into our equation that we just introduced in this section, so we can find the vertex, we can find the axis symmetry, and max and min. So going back to the video, if you need a refresher, this is going to be a quick one. If you need a refresher, please go back to 3.2 slides or my video to explain how to complete the square. But recall step 3, where we take the middle one, b, which is 10, divided by 2, square it. So that's going to give us 25. Remember to remove the 23. We're going to make a space, insert this inside, because again, 25 minus 25 is 0, so we didn't change the problem any. So, but we needed to insert this in so we can finish off the complete the square. So I'm going to put this part in parentheses because that's going to be our perfect square, and then I'm going to add these two together, and that's going to give us a -2 here. To complete the square here, this factors to be x plus 5 squared. So x plus 5 times x plus 5 gives us all this trinomial up here. So now that it's in this form, we can easily figure out the vertex. Again, change the sign. That's going to be -5. And then keep the same sign here, which is going to be -2. Axis of symmetry, always the x here. So x equals -5. This is going to be a minimum because the value, because it's going to be a positive equation, which makes a happy face, and the lowest point is going to be considered a minimum, which is going to be our y. So -2. You do not have to put for the minimum y equals -2. You can just write the answer here. But for axis symmetry, you must put x equals. So if we have a number in front, remember the first step before completing the square is we got to make sure our a in front is going to be a 1. So we take out a 2 here and here. So we're just going to slide this off to the side. We're not going to worry about the outside part, just with the x's here. Take a -2 out. That's half of 10 is 5. Then we're going to do our step 3. We're going to divide this 5 by 2 and then square it, and we get 25 over 24. I'm sorry, 25 over 4. The only thing is now when you factor out this -2, we have to do this, we have to multiply back into the part that we actually found before. So these two here, once you separate it and put it off to the side, make sure you take the -2 and multiply it to the new part that we found when we divided this by 2 and squared it. So once we do that, we add them two together, we get 1. We find the perfect square of 25 over 4, which is going to be 5 over 2. It's in the exact form of the equation, the quadratic equation. So then we can figure out the vertex. Change the sign here, positive 5 over 2. Keep the sign here as 1. X equals 5 over 2 for the vertex. Axis of symmetry. And then this one here is going to be a maximum because we have a negative here, so that makes a frowny face. And then whatever the y is going to be our maximum value for the function. So just a kind of like a recap, when it's in the inside, the negative, the minus in here make sure it shifts to the right 5 over 2 units, reflecting on the x-axis up here, stretching vertically because of the whole number of 2, and it's going to shift up 1 because of this positive 1 here. Now let's find the vertex of the parabola by hand. So this is the formula that we're going to use to calculate the vertex. It's going to be this is considered to be an ordered pair. So we have x, and this whole thing over here is supposed to be all y. So x coordinate goes here, y coordinate goes here. We figure out what our b is, we figure out what our a is, and then we're going to do the calculate and figure out what the problem should be. We get our a and b from the equation that's given. So identify what a and b are. Then we're going to substitute a and b, find the first order pair. Then once we find out what x is, we take our x and plug it back into the equation to figure out what the y should be. And we kind of briefly went over this for as max and minimum. We already know by looking at the positive negative of the first term here. But to figure out what the vertex is, my a in this case is -3. My b is going to be 12. So a is -3, b is negative 12, positive 12. Remember the negative on the outside of the equation also. There's a negative here. Got to keep that on the outside. So we do the math. We have -12 over -6 equals to 2. 2 is going to be my x in the order pair. So once I figure out my x, take the 2, plug it back into every x I see up here, and then solve and get our answer for y. So here 2, 2, I do the math, I get 7. So my vertex is going to be 2, which came from here, and 7. Once I plug that 2 back into the equation, I got 7. Just another reminder, the axis symmetry must be x equals, again, from the x and the vertex. So here, find the vertex again. Our a is going to be -1, b is going to be 14. So we take those two, -1, 14. We do our math. We get positive 7 to be the x. Take this 7, plug it into this x here, plug it into this x here. We do our math, and we get the answer to be 2 for the vertex. So since we have a negative in front here, we know it's going to make a frowny face, which makes the vertex going to be at the top as a maximum. So we know this is going to be a maximum. How do we know what the maximum value should be? It's always going to be the y in the vertex. So right here, when it changed direction, we know this is the highest point before it changes direction and goes back down. What is the range? How far down does this go? This graph here. So this kind of continues on down. I know it stops right here, but you have to pretend it continues on down to here. That's where we get negative infinity. And what is the how high does it go? If you look on the y-axis, because range deals with y, we go 1, 2, and we already know that from the vertex. Because the vertex, the highest point was 2, we already know that's going to be the highest value for y. So that's going to 2. So when you put your parentheses around the infinity sign, parentheses always get infinity because, again, the brackets mean you actually can touch or it goes through that point. The parentheses means it gets close and close to it but never touches it. Obviously, we can't never identify what infinity is, so we have to always surround that with parentheses. The 2, because it touches that 2 or equals that 2, we can put a bracket around that. So the range is from negative infinity to 2. When you're doing range and domain, remember the lowest number goes here and the highest one goes here because it's a negative, that's a positive, no, lowest, the highest. Part D, we already know it opens up downward, and then it's asking for when does it increase or decrease. So we see in this here, it increases all the way up until we get to set up to 7. X equals 7. 1, 2, 3, 4, 5, 6, 7 right here. So negative infinity to 7 is where we see the increase. The decrease is from 7 on down for here. And we always use the X values for increasing and decreasing. That's again back in chapter 2 when we talk about increasing and decreasing intervals. Now here is the same function, the same equation I'm giving you, but this time we're going to find the vertex using the calculator. So good way to check your work if you're doing it by hand. So we hit y equals, type in our equation, hit zoom 6 to kind of see what it looks like. We already know it looks like a frowny face because of the negative. If these values are going to be large values, what you need to do is hit zoom 0 for a larger number than the equation. But since they're fairly small, we can just hit zoom 6 and it can probably fit to what the graph should look like. But if you don't see the graph, maybe because it's too big or doesn't fit the window, hit zoom 0 and it'll fit it for you. So then we're going to take a little blinking cursor, go to the vertex. We're going to hit second trace. And this is where we choose whether it's going to be number 3 or number 4, a minimum or a maximum. Again, because in the negative makes the frowny face, we're going to have a maximum up here. We're going to choose 4. So we take the cursor, go to the left of the vertex, hit enter. Then we can go to the right. That's where it says left bound. Then we go to the right side of the vertex. We hit enter again. We hit enter one more time to bypass the when it says guess. And sometimes we might need to round the answer. So that should give us the vertex of 2, 7. If you ever see do an equation and you have an E in the result of the Y or the X, the answer will be 0. So we put 0 in either for here, if you see that little E. So just to quickly go over how to find the vertex again, and I'm going to show you this and this equation to go through those steps for you. So we're going to take this equation here and we're going to figure out the vertex because the problem asks for a model rocket has launched with an initial velocity of 100 feet per second at the top of a hill that is 20 feet high. So here's a rocket 20 feet high. We're going to shoot it up in the air. And I want to know what time in which the rocket meets these maximum heights. So here's the rocket going up. I want to know at this highest point, which is again going to be our vertex, what is the time and the height of this of the rocket. So we're actually going to find both of them. So we're going to go to our calculator, hit y equals. Let's type in the equation, -16. Now they use t, but you always have to use x when you're doing it in the calculator. So for any variable, always use the x. Plus 100 x plus 20. So then we're going to hit zoom 6. And we notice in the I don't see this graph doesn't look really perfect to me because I need to see if it's going to be a maximum or a minimum in order to do our second trace. So this is where the numbers are really big. So we're going to hit zoom 0. And zoom 0, all that says is fit. We're going to fit the equation into our calculator. So here we have now a nice parabola, which we can see where the vertex is the highest point, and we can calculate that. So this is where we hit second trace, and then again we have to determine whether we're going to use number 3 or number 4. Because we know it's a maximum vertex, we're going to hit 4. Here is the vertex. So if I take the little cursor and go right to the center where the vertex is, somewhere in the ballpark, my directions say you either go to the left bound 3 times. So 1, 2, 3. It's not necessary here. I just said 3 is a good marker, but anywhere on the left side is okay. And you just hit enter. Then I go back to the middle again, And now I want to go to the right bound. So I want to go to the right side. So remember where the axis of symmetry is, right down the middle. So go to the right. Anywhere over here is fine. So guess, I remember I just said just hit enter, just to bypass guess. And the calculator automatically puts it right at the vertex for us, 3.125 and then 176.25. So at 3 seconds, about 3 seconds, it'll be at a maximum height of 176.25. So the rocket reaches the maximum height of 176 when it at 3.125 seconds. So this concludes section 3.3. If you have any questions or concerns, please let me know.